or Port Address Translation, or PAT. But let's go back in the history for a little bit. When the internet was created and started growing bigger and bigger, all the people who had the money to buy computers were divided into two groups. There were those who wanted to join this global community, and there were those who said that they didn't want to go out to the internet, but they just needed some IP addresses to connect their computers into a private network. So IANA, or Internet Addressing Numbering Authority, the global organization that gives out IP addresses, said that those companies who are not going to the internet didn't use the main feature of the IP address, its global uniqueness, meaning that there are no two exactly the same IP addresses in the world. So they decided to separate all the IP addresses into two types: the public IP addresses that are globally unique and can be used to browse around the internet, and the private IP addresses that are absolutely everybody can use. They don't need to be specially assigned from any kind of service provider, but it's said that you can use those IP addresses in your private network and you cannot go out on the internet with them, since there can be IP address duplication because somebody else might be using the same exact block for its private network. For private use, IANA reserves 3 blocks from the 3 main classes of IP address. From Class A, IANA reserves the block 10.0.0.0 to 10.255.255.255, leaving this to be the public range from 1.0.0.0 to 9.255.255.255, and then from 11.0.0.0 to 126.255.255.255. So this, as we said, this is allowed, this is used only in private use, and these are globally unique IP addresses that you can go out on the internet with them. Now, in our example right here, the hosts in the private network are using exactly IP addresses from the range of Class A private IP addresses, and then let's say the Cisco and Yahoo servers are using IP addresses from the public range of Class A, and again, they're globally unique and they can go out on the internet and do whatever they want. From Class B, IANA reserved the block 172.16.0.0 to 172.31.255.255, and then leaving this to be the public IP address range. And for Class C, the IANA reserved 192.168.0.0 block to 192.168.255.255, leaving this to be the public IP address range for Class C networks. And in this way, everybody was happy. Company got their internal networking, and IANA reserved a lot of valuable IP addresses. However, the internet grew bigger and bigger, and eventually those same companies wanted to join the internet. But they just couldn't do it with their current networking scheme. Well, that's where NAT, or Network Address Translation, comes into play. NAT allows the companies to dynamically translate their private IP addresses into public IP addresses so they can go and browse on the internet. And most of all, they didn't have to change their private networking scheme. Well, let's see an example of how exactly NAT works. Imagine our host A is to send a packet to Cisco to now retrieve a web page. So for a source address, the host A will put his IP address 10.10.10.10, and the destination will be the IP address of Cisco. So when the packet is received by the route realizes that the source address is a private IP address and it cannot be sent to the internet. So it has to change this IP address. So NAT will dynamically translate the source IP address or change the IP address of the host A to a public IP address that is allowed to go on the internet. Let's say the IP address 70.19.34.15. Then the packet is sent to Cisco just as a normal packet. When the Cisco replies, the Cisco will reply to a host A with this public IP address because he's unaware of the network address translation that we just did. So when the packet is received by the router sees that the destination of the host A is 70.19.34.15. So it will actually translate this IP address back into the 10.10.10.10, which was the original IP address of host A, and it will forward the frame to the correct destination of the host. The way the NAT did this translation is by dividing the entire diagram into two worlds, the inside world or the private world, and the outside world, meaning the global world where everybody is. Furthermore, NAT divides all the IP addresses in those two worlds into two categories, local and global. So you can have an IP address called inside local, for example. An inside local is nothing more but than the private IP address that is being translated, the private IP address owned by the host that is being translated. In the previous example, the private IP address or the inside local address would be the 10.10.10.10 address. The inside global address is the public IP address that the inside local or the private IP address is being translated to. In the previous example here, the inside global address would be the public 70.19.34.15 address that the router changed the original 10.10.10.10 into. And then the outside global address would be the destination's public IP address, or the public IP address of the host that is located in the outside domain. 74.57.43.19 is the outside global address of our destination, or the cisco.com. And then we have the outside local address, which would be the private IP address of the destination. In most of the cases, we don't know the private IP address of the destination because it's being translated into the outside global address, which we know, which is the 74.57.43.19. So if cisco.com, the server for cisco.com, if it had a private IP address, that would be the outside local IP address. But as I said, most of the times we don't know it. So you might ask, why do we then need it? And that's a very good point, but NAT also can translate public IP addresses into private IP addresses, which is basically the reverse concept of what we're studying now, and from that perspective you would need to define the locals and the globals. Now that we saw how NAT works and the different types of IP addresses that NAT uses, let's see how we can configure NAT. Well, basically there are three ways to configure NAT. The most basic way is something called static NAT. Here we statically tell the router to translate a single private IP address or a single inside local address into a single public or global address. The way to do this is in global configuration mode, you type the command ipnet inside source static, then the private IP address that you want to translate into the public IP address that you want to be translated to. Remember, the private IP address is usually called the inside local, and the public IP address is called the inside global. That is good, but also now we have to tell the router on which interfaces he is connected to the inside world and on what interface it's connected to the outside world. The way to do this is by entering the command ipnet inside of the interface that the router is connected to the inside world, and ipnet outside inside of the interface that the router is connected to the outside world or is connected to the internet. Now the router then knows from which interface, if he receives the packet, to translate it into whatever interface and send it with the appropriate IP address. To verify all these commands, you can type the command show IPNet translations, and it will see all the translations that you have done. Of course, this command is typed in the privilege mode of the route. Now let's see an example of how we can do that. So let's see how we can configure static NAT. We're going to try to translate the host A into some public IP address so you can reach the cisco.com. Now, to do this in global configuration mode, we would have to type the command ipnet inside source static, and then the private IP address, and then the public IP address, right? For the private IP address, we will use the IP address for host A, which will be the 10.10.10.10, and for public, we'll just choose some public IP address that can be reached by the route. So, we'll have to type the command ipnet inside source static 10.10.10.10, and let's say the public IP address would be 64.10.75.99. After that, we have to specify on which interface the route is connected to the inside world and what interface is connected to the outside world. Well, we can see that the router is connected on FA00 to the inside world, For that reason, we'll have to type the interface fa0/0 to go into that interface, and then type the command ipnet inside. Now the router knows that this is the inside world, and then we'll have to type for serial 0/0/0, which we know that it's connected to the internet. We'll have to type the command interface 0/0/0/0 to go into that interface, and then type the command ipnet outside. And now the router knows that the outside world is connected to interface 0/0/0/0. So if host A is to send a packet to the Cisco.com, when it comes to the router will translate the address 10.10.10.10 into the 64.10.75.99, and the frame name will arrive normally at the Cisco server. Well, static NAT did its job, but if we have 200 hosts, then the picture gets uglier, because now we have to type 200 static NAT translations, and management of those different translations can be also tedious. Well, for that reason, dynamic NAT comes into the rescue. Dynamic NAT translates a private IP address into a public IP address for the time of a session that the host needs to go out to the internet, and after that the host releases this public IP address, allowing NAT to give that same IP address to somebody else who wants to go out on the internet. Well, to configure dynamic NAT, there are a couple of things that we need to do. Well, first, we have to provide the router with a range or a pool of public IP addresses that can be used to translate private hosts. The way to do this is in global configuration mode. You type the command ipnet pool, then the name of the pool, and then a starting IP address range, and then the ending IP address. This can be, let's say, 20 IP addresses only, or it can be all the IP addresses in a given network. You choose how big or how small this pool is going to be. After that, you have to type net mask, and then the subnet mask or prefix length, and just type slash notation the subnet mask. Why would you need to provide the subnet mask for those IP addresses? Well, you need to do this because, again, every single IP address has to have a subnet mask in order to figure out in what network does the IP address belong to. Needless to remind you, this is one big command. The command was ipnet pool, the pool name, starting IP address, ending IP address, net mask, the subnet mask, or prefix length, and then the prefix length. Now with that we have provided the router with a pool or range of public IP addresses, we need to tell the router who the private IP addresses are, or who is allowed to be translated. The way to do this is by the use of an access list. Remember, access lists had two uses. They had filtering and classification. Now we're going to use the second use of it, which is classification. For the purpose of NAT, you really don't need to configure an extended access list with all the different options, where a standard access will do the job. So, to specify to the router which private IP addresses are allowed to be translated, you have to type the command access list, the access list number, which since we said that we can use standard access list, the number has to be between 1 and 99, then permit, and the source IP address, and then the wildcard mask, where the source and the wildcard mask define which IP addresses, again, are allowed to be translated with the IP addresses from the pool. And now that we have specified the private range, we have to type the command ipnet inside source list, the access list number, and then the pool, name, in order to combine those things together, in order to make the NAT work. Now again, this command, all it has to do is just tells the NAT to translate any host that is allowed by the access list or that is classified by the access list with an IP address with an inside global address that is defined from the pool. And also, just like in static NAT, we have to specify to the router where is the inside world and where the outside world is located. We do those things with the ipnet inside and ipnet outside commands, which are defined in the config-if mode, meaning inside of the interface. Now let's see how we can configure dynamic NAT on a given example. Now, in our example here, we will translate, or we'll make a dynamic NAT translation that can translate all the hosts in 10.10.10.0 network to, let's say, a range of IP addresses that belongs to the network of the IP address of 0000, meaning the network 64.10.75.0. So to do this, the first thing again, we said that in global configuration mode, we have to specify a pool of IP addresses. To do this, let's say we can type IPNet pool, let's put the name of the pool to be test, and then the range of the public host to be from 64.10.75.80 to 64.10.75.99, meaning we're specifying 20 hosts. After that, remember that every single IP address has to have a subnet mask. That is why we're typing net mask and then a 255.255.255.0, which is the subnet mask of the IP address on the 0000 interface. Of course, I could have used the prefix list and specify slash notation, but I just prefer to use the net mask right here. After that, you have to tell the router which is the private world, or where the private world is located, or who is allowed to be translated. All those things to do this thing is you have to type the access list. Well, based on the IP address of the private world of host A and the subnet mask, that means I have to type an access list 10 permit 10.10.10.0 0.0.0.255. The number 10 tells me that this has to be a standard access list. That is why I'm not specifying either destinations, no protocols, no anything like that. And the 10.10.10.0 with that wildcard mask will allow me to specify all the hosts within this network. And now to type, we have to type the command that makes everything work. And the command is IPNet inside source list 10 pool test, where the list 10 is the access list number, and the pool test is the name of the actual pool that we have specified for the public world. Now this, remember, this will tell the router to translate any host that is classified by the access list 10 to some IP address from the actual pool of public IP address. And then just like a static NAT, we have to tell the router where the inside world is and where the outside world is. Well, the inside world for router A would be connected to FA00. That is why we're going to that interface with the command interface FA0/0 and then typing the command IPNet inside. Now the router knows where the inside world is, and then we know that the 00/0/0 is connected to the outside world. That is why we're typing interface 00/0/0 and then IPNet outside. And that's it. That's all you have to do for dynamic NAT. Specify your pool, specify your access list, combine those two things in the IPNet inside source statement, and specify the inside and outside world. Now, if host A wants to get to the cisco.com, when it comes to the router will check the source IP address against the access list. In this case, the IP address belongs to the network that is specified by the access list. That means that this packet will be classified as special, so the router can actually translate it into, let's say, the first IP address from the actual pool, which is 64.10.75.8. Then this packet can go on its way. And now if you have host C sending a packet, when the packet is received by a router A, the router A will see that the IP address of host C also belongs to that network, and we use that network. Any IP address that belongs to that network will be translated with a public IP address. So router A takes out a second public IP address from the pool, whatever is free, and translates the host C. So host C will have an IP address 64.10.75.81, and then the packet can go also on its way. Well, NAT did its purpose of translating the IP addresses, but in order for NAT to work properly, we had to have a different public IP address for every single private IP address, or a different inside global address for every single different inside local address. However, in most of the cases, we actually won't have an entire pool of public IP addresses to play with. As a matter of fact, in most of the times, we'll have only one public IP address, and that address will be assigned to the router 0000 interface, or the one that's going to the internet. So how can we translate all the private hosts so they can go out to the internet? Well, port address translation, or PAT, can help us with that. In PAT, there are still two worlds, the inside world and the outside world. However, PAT will translate all the inside local addresses with the inside global address that the router has on its interface connected to the internet. In our case, that IP address will be the 64.10.75.34. So let's see how the router does that. Well, imagine host A is to send a packet, or is to open the Cisco web page. When the frame arrives at the router will have the following information. For the inside local address of the private IP address, or the address of the source, the router will have, let's say, the IP address 10.10.10.10, and maybe we can say that the source port will be 5097. The destination would be the IP address of the cisco.com, which is 74.57.43.0, and a destination port 80. Now, the router, it is to translate the inside local into inside global. He has no chance but translating it into the IP address of the 0000. So he'll translate the 10.10.10.10 into 64.10.75.37, and let's say a port number 5097. Now the frame can continue to its destination. But if we have host C opening the Yahoo web page, and let's say the packet has an inside local address of 10.10.10.30 and also port number of 5097 as a source port, and the destination or the outside global would be the IP address of the Yahoo, which is 67.14.35.20. Well, now the router has to translate the inside local into inside global. But then what the router is going to do? Well, no problem at all. The router will just have to use a different source port number to translate the frame. So what the router actually does, or what PAT does, is changing the actual source port in the level 4 header in order to differentiate between the different translations that we just did. In our case, to translate 10.10.10.30 with the source port 5097, the router used the IP address of the 000 interface and a source port 6021 because the 5097 was used by the different translation that we translated the host A's session. If a host A is to open another web page, but this time the Yahoo web page, the frame will have a source IP address 10.10.10.10 or the inside local IP address and a different port, a different source port. Let's say this time is 9000. Well, but the router, if already used port 9000 for some other translation, then the router can translate this particular frame with some other source port. And in this example, we can use port number 8701. And I'm sure you already picked this up, but the source address on the inside local and the source address on the inside global do not have to match. As a matter of fact, as long we don't really care if they match or not. As long as the router keeps up a table where it says that if a packet with an IP address 64.10.75.34 and a port number 6021 comes in, it has to translate it into 10.10.10.30 with a source port number 5097. We really don't care if those ports match or not. Configuring PAT is almost the same as configuring NAT. The only difference is that now we don't have a pool of public IP addresses to play with, but we have only one IP address, which is the IP address of the interface on the router that is connecting to the internet. But we still have to dynamically specify which private hosts are allowed to be translated using the access list command, which is typed in global configuration mode. Again, just as in NAT, access list can be an access list, which will be totally fine for the purpose of NAT. After we type the command after we specify the host with the command access list, we have to type the command ipnat inside source. But now the command differs slightly from the command that we use to configure dynamic NAT. Let's see, for PAT, the command will look something like this. ipnat inside source list, where the list number is the access list number that we use to specify private host. And now for public IP addresses, we will specify that we want to use the IP address of the interface, that is the interface that is connected to the internet, or the interface that has the public IP address, and then the keyword overload. The keyword overload does the actual job, does the actual path. What does it do is it tells the router to use port numbers to translate the private hosts that are specified by the access list into a public IP address that is defined by the interface IP address and port numbers. Also, just like in the previous NAT that we've studied, on PAT you still have to specify the IPNet inside, to specify the IPNet inside world, and the IPNet outside to specify the outside world. So let's see how we can configure PAT. Well, we would need to configure an access list, and based on the IP address of the host A, I have to type an access list 10 permit 10.10.10.0 0.0.0.255 with a wildcard mask in order to specify that every single host within the network 10.10.10.0 is allowed to be translated to a public IP address and go onto the internet. After that, we can type the command IPNet inside source list 10 and then the interface 00/0/0 and the keyword overload, where the list 10 again is the access list number that we use to specify the private host, and then the interface 00/0/0 is the interface that is connecting to the internet. It's the interface of the router that is connected to the internet. And the keyword overload again is the actual key that does everything. It's the actual thing that does the entire PAT translation, which tells to the router to use port numbers to translate the different hosts. After that, we still have to specify the inside world, and in this case, router A FA0/0 interface is connected to the inside world, so we're going to that interface and then type the command IPNet inside. Then we have to go to the interface 00/0/0 because that interface is connected to the internet, and type the command IPNet outside. Now, if host A is to send a packet to yahoo.com, it will have, let's say, IP address 10.10.10.10 and a source port, let's say 7011. When the packet is arrived at the router will change this thing into an IP address 64.10.75.34 because that is the IP address of 000, and it probably is going to use the same source because the port number 7011 is not used in any other translation. And the packet can go to the yahoo.com. And if host C is to send a packet to Cisco, and the host C is using a source port of 1500, when the packet arrives at router A, and if router A determines that the port 8500 is already used, it will translate the packet into an IP address 64.10.75.34, which is again the IP address of the interface 000 on the router, and a different port source number, which will be, let's say, 9019, which allows the packet to go to cisco.com. But we can also configure PAT even if we have a pool of public IP addresses. Configuring dynamic NAT with overloading, if you want to call it like that, doesn't change at all when configuring regular dynamic NAT. Well, we still have to provide a pool by typing IPNet pool, the name of the pool, starting IP address, ending IP address, and the subnet mask. We still have to use an access list to specify the private world. And again, this access can be a standard access list. And we still have to type the IPNet inside source command. It's just that now the IPNet inside source command, after it's specifying the access list and the pool name, we have to type the keyword overload. And what does the router will do is it will start translating all the different hosts with the first IP address from the pool. And when it runs out of all possible ports on that IP address, it will basically pick up another IP address from the pool and start translating all the hosts with that IP address. And just like any NAT or PAT that we've studied so far, we still have to specify the inside world using the command IPNet inside and the outside world using the command IPNet outside. To configure it, it's almost everything is the same. So all you have to do is in global configuration mode, IPNet pool, the name of the pool, starting IP address could be from 80 to 99, the subnet mask 255.255.255.255.0, which will place all these hosts in the network or in the same network as our IP address that we have on the route A 00/0/0 interface. And again, this pool will be the pool of inside global addresses, so the public IP addresses that all the private IP addresses will be translated into. Then we have to type an access list, and based on the host A's IP address, the access list would look access list, the access list number, permit, the network 10.10.10.0 with a wildcard mask 0.0.0.255. After that, the command IPNet inside source will have a list of 10. The pool will be the test pool, and then the keyword overload that does everything. Again, the list 10 comes from the access list number, and the pool test comes from the actual pool. that we have specified with the public IP address. And the keyword overload makes dynamic NAT into PAT. After we type those three commands, we have to specify which interface the route is connected to the inside world, which interface the route is connected to the outside world. So we have to go to interface FA0/0 to type IPNet inside, then go into interface 00/0/0 and type the command IPNet outside. And this will give us the outside world. So if a host is to be translated, it will be picked up the first IP address from the pool and whatever the source number or whatever the source port is. Then if another host comes up with a given port number, with a given source port, the route will translate that same host with whatever the first IP address from the pool is, a different source port number, or maybe the same source port number if the original source port of 8500 is not used in any other translation. And that's it. That's all you have to do to configure dynamic NAT with overloading. You still have to configure it just like a regular dynamic NAT, but instead of just typing IPNet inside source list pool and then the pool, you have to type the keyword overload after that. To verify NAT, all you have to do is type show IPNet translations in privilege mode, and this command will tell you all the translations that you've done between the inside local, the inside global, and so forth and so forth and so forth. Now, in the output of router A, you will see something like that. Inside local, the private IP address is 10.10.10.n, and the source port is 7011, and the inside global is 64.10.75.34, with a source port also 7011. And these ports are coming from protocol TCP, which is the layer 4, and it's the same in this case. And the outside global, the public IP address of the destination is 74.57.43.19 with destination port 80, and the outside local is also the same, 74.57.43.19 port 80, because we have no way of figuring out what the actual private IP address of the destination is, and that is why Cisco fills up the outside local with the same IP address as the outside global. Now, that's all you need to know. Remember, what we did in this lecture, we talked about the public and private IP addresses and why do we have those public and private IP addresses, and also how we can translate from public to private using NAT or port address translation, meaning PAT, and then we've configured and verified NAT and PAT. Well, that's it. That's all you need to know for the test, and thank you for studying CCNA with Vanbar.